Okay, today we're going to learn to reflect a function across the x-axis. So what that means is if I had a function, let's just do the absolute value of x function, and if I was going to reflect it across the x-axis, it would take every point and move it across the x-axis. So in this case, the new function would be this dashed line, where you just flip that across the x-axis. Remember, you talked about in our earlier algebra classes or geometry classes, a reflection is a flip. And so if we flip it across the x-axis, we would see this new graph. The rule for reflecting a function across the x-axis: if g of x is a reflection across the x-axis of f of x, then g of x equals negative f of x, or negative 1 times f of x. Effectively, what this does is change the sign on every term in f of x. So we're multiplying every term by negative 1. We will look at two examples. If I was given a function, g of x, or given a function f of x, and asked to find g of x when g of x is a reflection of f of x equals x squared minus 3x plus 4 across the x-axis, then I know the rule says that g of x equals negative f of x, or negative 1 times f of x. So this is negative 1 times, we replace the f of x with what it's equal to. It's equal to x squared minus 3x plus 4. So this becomes g of x equals negative x squared plus 3x minus 4. If you would stop the video, graph f of x equals x squared minus 3x plus 4 on your calculator, and then graph g of x equals negative x squared plus 3x minus 4 on your calculator in y2, this one in y1, this one in y2, and verify that these are reflections of each other across the x-axis. In example 2, we're going to do find g of x if g of x is a reflection of f of x equals 3 plus the square root of x minus 2, with x minus 2 under the square root, across the x-axis. So again, use the rule, g of x equals the opposite of f of x, or negative 1 times the f of x. So that's negative 1 times, and in my parentheses, 3 plus the square root of x minus 2. Now recall, we can't distribute the negative 1 inside the square root, so this just changes the sign on everything outside. Negative 1 times 3 is negative 3, and negative 1 times the square root of x minus 2 is negative square root of x minus 2. This is g of x. Again, verify. Graph this on your calculator, and then graph this on your calculator, and see that there are reflections of each other across the line, or across the x-axis. What if we look at some like we saw earlier? Let's say we have the function given by table, where we're given x and f of x. Let's just do negative 2, negative 1, 0, 1, and 2. And we'll make up some values here. Let's do 8, negative 7, 6, negative 5, and negative 3. So this tells me that f of negative 2 is 8, f of negative 1 is negative 7, f of 0 is 6, f of 1 is negative 5, and f of 2 is negative 3. So if I said find g of negative 1 if g of x equals f of x, or sorry, negative f of x. This tells you that this is a reflection of f of x across the x-axis. When you see g of x is negative f of x, the rule that we studied on the last page tells us that this is a reflection across the x-axis. If we want to find g of negative 1, then we're going to plug in, or sorry, we're going to graph. Let's just look at it on the graph. If we have negative 1 and then negative 7 on the graph, if I was to reflect that across the x-axis, it would flip all the way across, and it would be the same distance above the x-axis as it now is below the x-axis. So that would take this point to negative 1, 7. So in this case, g of negative 1 would be equal to 7. Now look what it did. It just changed the sign on the y value. It's the opposite of f of x. So if I plug in negative 1 here, g of negative 1 is negative f of negative 1 when I replace the x's with negative 1. Well, negative f of negative 1 is negative 7, so this is just negative negative 7, which we know a negative times a negative makes a positive, so g of negative 1 is equal to 7. That's two different ways you can do those. Then let's look at one where we're given a graph of a function. And this time I'm just going to plot a series of points for time and brevity's sake. And let's say this function is made up of the points. Well, let's go ahead and graph it. Oops, put that point down here. And we'll call this function f of x. And if I told you to find g of 0 if g of x equals the opposite of f of x. Well, that means that g of x, this rule tells us that g of x is a reflection of f of x across the x-axis. So I find a point where f of 0, let's say g of 0, equals negative f of 0. So f of 0 is negative 2 on this one. So the opposite of negative 2 is positive 2. And if you think about the point on the graph, if we flip this across the x-axis, it would go from 0, negative 2 to 0, 2, so that g of 0 would now be positive 2. And that's how we reflect functions across the x-axis.